This is the video for homework 7 and 8. Some of these are a little bit tricky, so I just wanted to get you started on them. Let's take a look at number 1. So number 1 is in a table, and it's asking us to determine if y and x are proportional. So one of the things you might do is grab a pencil and start looking for the change in y over the change in x, right? We call this the rate of change. And so let's give it a shot. All right, it looks like the y goes from 12 to 20. That would be a change of plus 8. And it looks like 20 changes to 8. That would be a change of minus 12. And then 8 changes to 32. That would be a change of plus 24. And you might stop right there and just assume that this is not a proportional relationship because the rate is changing by different amounts. Let's just check the x here and follow through. 3 plus 5 would be a change of plus 2. 5 to 2 would be a change of minus 3. And 2 to 8 would be a change of plus 6. So what I'd like us to do is just think about these different changes, right? So let's take a look at the first one. Change in y is 8. Change in x is 2. That would be a change of 8 over 2. The next one, the change in y is 12. And the change in x is 3. That would be a change of 12 over 3. Now those are both negative, but it won't matter. It's 12 and 3. And the last one is 24 and 6. 24 and 6. And you might say, great, I told you these are all different. But if we look closer, if we simplify these, we will see that that is a change of 4 over 1. If I simplify this one, it would be a change of, and just for you advanced learners, I'm going to divide by negative 3 here, but dividing by 3 would give us 4 over 1. And here, dividing by 6 over 6, simplifying it, would give us a change of 4 over 1. So we can see that these may all look different, right? These changes in y and x may all look different, but they are actually equivalent. They are all 4 over 1, 4 over 1, 4 over 1. And that gives us a rate of change of 4. You might have noticed already, if you tried a different strategy, that they all have the same rate. 3 times 4 is 12, 5 times 4 is 20, 2 times 4 is 8, and then you would say, see, they do have the same rate. Just wanted to show you this because if you use the change in y over change in x strategy, you might have gotten tricked. All right, so I'm just going to give a little background here, a little story. Imagine these were chips. I bought 3 bags of chips. They were $4 each. I had to pay $12. This would be my input. I put 5 bags of chips in my shopping cart. The store charges me $4 per bag. I have to pay $20. The result is $20. My input is 2. If they charge me $4, then my cost would be 8, or the output would be 8. And so we see that the rate is the same for each one of these. Okay, cool. So that was a little bit of a tricky one. It is proportionate because it has a constant rate and a constant rate of change. Let's take a look at number 2. Number 2 is also tricky because at first glance it looks like the rate of change is the same, right? If for every 1/5 that x increases, goes up by 1/5, goes up by 1/5, goes up by 1/5, y increases by 1, plus 1, plus 1, plus 1. And what I'd like you to remember is that that is just the line. That constant rate gives us a straight line, right? You might imagine that for every 1/5 x increased, every 1/5 x increases, y increased by 15. For every 1/5 x increases, y increases by 15. For every 1/5 x increases, y increases by 15. And these points would in fact give us a straight line. But that's not all we need to know. We need to know if it is going to go through the origin or not. So let's go back to our rate of change and see what's missing. Imagine there was a number up here before 1/5. What came before 1/5? Well, I added 1/5 to it, whatever it was, and it equaled 1/5. It must have been 0. 0 plus 1/5 equals 1/5. Right? So the rate is constant. Over here, we were adding 1, constantly adding 1. That means the number above 15 must have been 14. 14 plus 1 is 15. So it looks like our line would have crossed at 0, 14. And so that means that it is not proportionate. Now, we didn't need to make the graph to show that. We could have just looked up here and saw that this was 0 and 14. Another way you could have found that it was not proportionate is by asking yourself, what times 1/5 is 15? And I'm not going to go into that right now, but I think that was 75. I think this one is somewhere around 60. I'm just kind of estimating these. I think this one might have been something like, well, I don't know at this point. I just know that these were different. And we'll talk about dividing fractions later. So those two are very tricky because if you just look at it in one way, you'll think that it is proportionate or not. But if you look at it more carefully, you'll realize you may have been wrong, right? So we have multiple strategies. It is a good idea to use more than one strategy to check your answer. All right, real quick. You and your friends go to the movies. The cost of admission is $12.50 per person. That is a ratio. It says create a table showing the relationship. So I'm just going to start out with the one that they gave me. $12.50 is money. I'll put it on top. And that's for one movie ticket, right? One person. They want us to complete the table. Sure, I'll complete the table. I'll put in 2 people. That would be a total of $25. I'm picking easy numbers here. What if 10 people go? I know that that would take the $12.50 and move the decimal one place over. So $125. I'll pick 100 people. I know that moves the decimal places, the decimal 2 places over. So instead of being $12.50, it's now $1,250. And then I'll pick one that's not so easy, like 7. And I would have to ask myself, what times 7 is, or I'm sorry, $12.50 times 7 people would be how much, right? And I don't know that right now, but I'll wait for a minute to check it out. Now, what they're asking us to do here is use x and k, that's the rate, put it down here, and y to write some equations. And you might not know this, but you've really used these equations already when you fill out the table, right? So let's think about the first one. I was taking the number of people who went to the movies, and I was multiplying it by the rate, and it was telling me the cost to go to the movies, right? So that's one equation. And I can check it out right here. I would multiply the x number, $7, times the rate of $12.50, right? And I would write $12.50 times 7, and we'd get 14, 15, 16, 17, $87.50. I would get the cost. I would get the y value. That would be $87.50. So erase this and write in $87.50. Okay, so that's one equation. You could stop right there. Now the other equation you probably already know. If I take the y value and I divide it by the x value, right? I take any one of those prices and divide it by x, right? $125 divided by 10, well, that would give me the constant of proportionality, right? So that is another equation that is very helpful when working with ratios. Okay, at the end of the summer, Betsy has saved $150 from her summer job. I'm just going to underline that. This was an initial deposit into her bank, and as the school year starts, Betsy is going to deposit $15 each from her allowance, $15 each week. Okay, there's a ratio right there from her allowance. Is her account balance proportional? So let's just think about this. Let's just start with 0, so we can check the 0. Before school starts, before she starts getting her allowance each week, before the ratio starts, does she have any money in the bank? Yeah, it says that she saved $150. So I'll put 150 right there. And after the first week of school, she's added 15, right? So 1 week goes by, she adds $15 to her bank account, and now we have 165. And we're going to finish completing the table, but, well, you will in your homework, that'd be great. But let's just stop right now and see if we can answer the question, is this a proportional relationship? And the answer is no, right? It's because at 0 weeks, she had $150. So the initial spot on any graph is going to be 0, 150, right? Let's add one more. After 2 weeks, if we add another $15, she'll have $180. So this is one reason why it's not proportional, right? It doesn't go through the origin, but let's prove it. Ask yourself, what times 1 is 165? 165. Ask yourself, what times 2 is 180? It's only 90. So we can see that they have different rates also. Let me just switch color here. Different rates. So yes, it doesn't go through the origin, and we can check by proving that they have different rates. Okay, that's it for today. I hope that's helped. Please, if you have any other questions about your homework, bring it into class.